there's one thing new to learn, it's how lake ecosystems work. And I'm a trained limnologist, basically somebody who studies freshwater ecology, especially in lakes. And there are some fundamental terms that I guess I'd like to cover before getting into Island Park Reservoir itself, because what's going on here is, or these fundamental processes are really critical to understanding Island Park Reservoir and its water quality. So the big term I'd like to introduce is the idea of eutrophy or a eutrophic system. It's a Greek word. It basically means hyperproductive. And this is something that happens to lakes all across the nation, and it's happening in Island Park Reservoir as well. So all lakes stratify, essentially. So they thermally stratify. In the spring, once the ice comes off, this upper layer of water warms. And one of the fundamental principles of water, one of the fundamental chemical principles, is that its density changes with temperature. The warmer that water gets, the less dense it is. Eventually you get to a point where this upper layer of water, this warm upper layer is light enough, it's like enough of a density difference with cooler water underneath that wind can no longer mix the entire water column together. So you've got these two separate bodies of water within a reservoir, like Island Park Reservoir. When once that first happens in the spring, everything will be nice and mixed, oxygen throughout, and everything looks pretty good. Water's nice and clear. What happens in a eutrophic system is that you get high enough nutrient input from the watershed to produce algal and cyanobacteria blooms. That's the green stuff floating on the surface of the water. Algae can be good or bad. Algae is the base of the food chain in lake ecosystems, but if you get cyanobacteria, that's what we call the harmful algal blooms that have made the news in Toledo, Ohio, and Lake Erie. They happen in lakes all over the country, and they can happen here as well. You get that algae and cyanobacteria growth. They absorb all of the light that's hitting the reservoir. None of that light gets down to the bottom sediment, so there's no plant growth. That algae and cyanobacteria dies and sinks to the bottom. Now, remember, this is two separate bodies of water within a singular body. The cyanobacteria and the algae can sink to the bottom, but then when they decay, they use up oxygen. And because of those density differences, there's no real exchange of oxygen from the surface layer of water to the bottom layer of water. So you lose all the oxygen in the bottom part of the lake or reservoir, like Island Park Reservoir. That creates chemical changes and unstable sediments that allow phosphate, basically more nutrients, to be released from the sediment. Those diffuse or are mixed in the fall to the surface. That causes more algae and cyanobacteria growth, and it's this cycle that can be really difficult to break. This is a eutrophic, hyperproductive system. In contrast, and in lakes like Island Park Reservoir, where the outflow is coming from this bottom layer of water, this is the pipe through the bottom of the dam pretty much. There's more details to that, but essentially it's a pipe through the reservoir. And that means that in a eutrophic system, you're going to get increases in the amount of nutrients coming out of the reservoir, potential increases in the amount of sediment, organic or inorganic, coming out of the reservoir, and less dissolved oxygen for sure. Now, thankfully, in Island Park Reservoir, there's structures that reoxygenate the water. So the low dissolved oxygen, thankfully, is and that's something we've worked with DEQ on, with Fall River Rural Electric Cooperative, in order to prevent that issue, but these other issues are definitely there. In what we call a meso or a oligotrophic system, basically not productive systems. Again, we use a lot of Greek words in this field, but you don't get, if you've got these lakes have low nutrient input from the watershed. They don't get heavy algal or cyanobacteria growth, usually just enough to keep things like fish and zooplankton alive, but that allows the sunlight to penetrate deep enough to cause rooted vegetation to grow. That rooted vegetation stabilizes sediment, it absorbs nutrients, and it keeps the water oxygenated. And there's minimal decay so that bottom layer of water stays well oxygenated throughout the year. Now, there are certain risk factors for eutrophy in a waterway. A larger watershed, a high phosphorus